welcome to the lesson on word problems in Unit 8. We're going to use the graphs of quadratic functions in factored form to answer problems about the real world. Let's say that your science class designed a ball launcher and is going to test it by shooting a tennis ball straight up into the air from the top of a 15-story building. They determined, that is the science class, determined that the motion of the ball could be described by the function h of t, or the height after t seconds, is equal to negative 16 times the time squared plus 64 times the time plus 80. Now t is the time the ball is in the air in seconds, and y, in other words, h of t, those are the y values, represents the height in feet of the ball above the ground at time t. The questions you might be wondering about, what are the maximum height the ball gets to, and at what time will the ball hit the ground? Well, listen, use what we know about these graphs to help us answer those questions. Now, if I try to do this in factored form, I'm going to take out the greatest common factor first. Negative 16 is the greatest common factor, and if I divide all the terms by that, I get negative 16 times t squared minus 4t minus 5. Okay, so then I look for any special cases. It looks like negative 5 is not a special case, so I'm going to factor it as usual. So I have y equals, and it's going to be negative 16, and it factors really nicely into t minus 5, t plus 1. I'm not going to go over how I got those numbers. You should know that from all the factoring practice we've had in this chapter. Now, from what we know, because the leading coefficient is negative and very far away from 0, this thing is going to open downward and be very narrow. It's very far away from 0, so I know that this parabola is going to be really high and really narrow, kind of like this, and open downward. Now, the maximum height of the ball, if the y values are the height, the maximum height would happen at this point here, and we have a very special name for that point. It's the very top or the very bottom of the parabola. It is called the vertex. So the vertex in this situation will get us the highest height that the ball will reach out of the ball launcher. But in order to find the vertex, we have to find the axis of symmetry. In order to find the axis of symmetry, we have to find what the x-intercepts are. So I'm going to set this equation equal to 0, and I'm going to use the zero product property to determine that at time equals 5 and time equals negative 1, therefore at time equals 5 and time equals negative 1 seconds is when the x-intercept will be achieved, I guess. I didn't know what word I was going to use there. So those are the two times it work. What's the problem with this problem, or this time right here? Well, time can't be negative, so it has to happen at time equals 5. That's when the ball will be on the ground. It'll be 0 feet above the x-axis. So 0 feet above the ground. So if I try to graph that, and I'm going to need a lot of space here, so I'm just going to pretend the ground is down here. And even though the time can't be negative 1, I'm just going to graph it just for the heck of it. Here's time equals negative 1, and there's 0. And then 1, 2, 3, 4, 5. There's time equals 5. And so I know that the x-intercepts of this situation are going to be at negative 1 and positive 5. Now I can find the axis of symmetry. The axis of symmetry is the average of those. So I do negative 1 plus 5 divided by 2. That's going to be 4 divided by 2. That's 2. So x equals 2 is the axis of symmetry. So I'm going to draw that now. Now I need to find that vertex, the highest point. And again, it's going to be very narrow. It's going to open downwards. So all I need to do to find the vertex is plug that x value in to the equation for x. So it's going to be y equals negative 16, and it's going to be 2 minus 5, 2, not t, plus 1. It's going to be negative 16 times the negative 3 times the positive 3. That's going to be negative 9 times 16 is going to be 144. That's a really high height, 144 feet. So I only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'll go by tens, I think. 10, 20, 30, 40, 50 is the height here. 60, 70, 80, 90, 100. And 140, 150. So right here, so 144 would be the maximum height. It should be about right there on my graph. And now I can see what the maximum height of the ball would be. It'd be 144 feet at the vertex. Now, when the ball is launched, it's at 80. At time equals 0, if we put 0 in here, it should be 80 feet off of the ground. So there's another point for you. That's 2 away from the axis of symmetry. And now I have this parabola that I know how to graph from all the other videos in this unit. And there you have it. But it's important to note that over here, before time equals 0, doesn't actually exist, right? I mean, we start at the top of this building. If you want to draw a picture, you can imagine if I go straight up and down, this would be the maximum height of the ball. And there we've used factored form of a quadratic equation to answer questions about something that you might be interested in. Let's do the same experiment, but now we're going to do it off of a 30-story building. And again, t is the time in seconds, h of t is the height in feet. So to figure out what the maximum height of this ball would be, I'm going to do the same thing. I'm going to factor in negative 16. I get t squared. Now notice this is a plus, so that's going to become a minus. 144 divided by 16 is 9. T, and 160 divided by negative 16 is negative 10. This one again will factor nicely. So now I know that h of t, or the y value, is equal to negative 16, and it's going to be t minus 10, t plus 1. Very similar problem to the one before. And again, if I want to know the maximum height of the ball, I need that vertex, which means I need the axis, which means I need the intercepts. So to find the intercepts, I need to set those factors equal to 0, because y will be 0. Okay, t minus 10, t plus 1. Oops, I didn't mean to do that. One second, let me move that back there for you. Oops, I did my mouse here. There we go. All right, let's try that again. So the intercepts, I know that t plus 1 has to equal 0, so time, again, is at negative 1, or time has to equal positive 10 seconds. So this is the one we want to use. That's going to be negative, so we don't want to do that. So time equals 10 seconds. The ball will be at the ground. To find the maximum height, I find the average. It's going to be 9 divided by 2, 4.5. Okay, so that's my x value. To find the vertex, I plug that in. Go ahead and plug that in now. It's going to be negative 16, and it's going to be 4.5 minus 10, sorry, minus 10. 4.5 minus plus 1. Okay, so we have negative 16 is going to be negative 5.5. It's positive 5.5. Use my calculator quick to help me out. Let's go ahead and bring that on the screen. Half times 5.5, that's negative, times negative 16. 484 feet. Holy cow, it's even bigger than the last one. And that makes sense because I'm a lot higher off the ground. I'm 30 stories off the ground. So I have a higher initial velocity of 144 instead of that, I think it was 80 last time, or 100 and something. Okay, so let's graph this. Again, x-axis, I'm going to make that go by ones. Then one of the x-intercepts is at negative 1, which won't actually exist, but I'll graph it just for the parabola's sake. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hope it should be at 10 though. There we go, 10. So it's negative 1, positive 10. We'll graph 5 just for good measure. Oops, I didn't count right then. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be right here. Again, it's okay to make mistakes. We all make them. We'll erase that and just graph it again just to make sure that it's all good to go. My vertex has to be 484, so I have to make sure I count by maybe 20s. 20, 40, 60, 80, 100, 200. Oh, that won't even fit, so I'm going to have to go by 25s, I think. All right, we'll go by 25s. So that's 100, 200, 300, 400, 500 up there. So each block is 500 on the y-axis. Axis symmetry is at 4.5. My scale on the x-axis is 1. I can just go to 4.5 here. 44 is going to be right about there. I'll make it a different color so it's easier to see. There's the highest point, probably right around there. X-intercepts. When time is 0, if I plug in 0 into this equation, I know that the height is 160. So 100, 150, 160 is about right there. I have another point in my axis of symmetry here, probably about right there. And here's my parabola. Again, very high, very narrow, because my a value is very far away from 0. And there you have it. 484 feet is the highest point in the flight. It hits the ground at 10 seconds again. So again, pretend like this is a building. I shot a lot harder, it looks like, and it finally lands on the ground over there.